Farkas Kempelen, a Hungarian inventor, created the first speech synthesizer of the world at the end of the 18th century. His idea was more than 200 years ahead of his own age. Now, at the beginning of the 21st century, speech synthesizers are built into almost every digital device. Listen to it.
That's why this machine is exhibited in the IT building of BME.
Kempelen's machine was rebuilt in Hungary in 2001 by Péter Nikléczy and Gábor Olaszi in original size and form. Kempelen's book, published in Vienna in 1791, and its Hungarian translation from 1986 were the main sources for this reconstruction. The main parts of the machine are as follows. The bellows stand for the lungs. You have to press it with the elbow of your right hand to make air pressure. A counterweight restores it to its original position. A wooden cover with 8 holes hides the speech generation mechanism of the machine. Controlling this sound box is performed with both hands. You have to insert the right hand through the back hole to reach the keys. Insert your left hand through the side round hole to form the shape of the mouth. The voice generation is produced in the small hermetically sealed wooden sound box. The bellows is attached to the back of the box. The first part contains a vibrating reed inside. The airflow coming from the bellows makes the reed vibrate, producing a voicing-like sound. There are 3 keys on the top of the box. The 2 outer keys serve to open the inner valves of the right and left outer resonators, and the middle one to generate the R sound. The nostrils are imitated by 2 small copper tubes. The resonator protruding to the right of the sound box is used to produce the F sound. The resonator on the left produces the sh sound. The mouth of the machine is an elastic rubber funnel. The inside of the rubber funnel is connected by a pressure compensating tube to the inside of the sound box. This plays a role in producing the P and T sounds. A small pressure boosting auxiliary bellows can be found under the rubber funnel. It also plays a role in producing the P and T sounds. The cross-section of the sound box shows the way of airflow when producing speech sounds. By default, in the case of vowel-like sounds, the air flows from the bellows into the box. Then it passes through the vibrating reed. Finally, a loud voice is produced at the end of the mouth. When producing oral speech sounds, the nostrils should be closed. The sound is then transmitted through the mouth. For nasal sounds, we close the mouth with our left palm, leaving the nostrils open. The result is a nasal sound. The 2 inner small wooden valve boxes play a role in creating the F and sh fricatives. The mouth and the nostrils are then closed. The valve cover is lifted with its external key to direct the air towards the resonator F or sh. If you want to make a voice stop, you have to close both the mouth and the nostrils. The air flowing from the bellows then also feeds the auxiliary small bellows. In this case, the pressure is the same in the sound box, in the rubber funnel, and in the auxiliary bellows due to the pressure compensating tube. The vibrating reed does not vibrate. If the mouth is opened, suddenly the air will escape and the voiceless stop sound will be generated. Now let's look at some of the real controls of the machine in producing the word papa.